Number one, the radius and area of a circle are related by the equation a equals pi r squared. Okay, so we want to write an equation that relates dA dt to dr dt. So basically we're not solving for anything, we're just doing implicit differentiation. So we're just doing d dt of both sides. Okay, so on the left side it's just dA dt. On the right side, well, just look at pi r squared, so that the 2 is going to go to the front, so it's going to be 2 pi r to the first times dr dt. And that's it. That's all you have to do there. Make sense? Questions? That was just implicit differentiation. We didn't even have to plug anything in.
So your tablet.
I did. Okay, number 3.
Oh, there's 3 parts to it.
3 parts to number 3?
Yep.
Okay, radius, height, and volume of a right circular cylinder are b equals pi r squared times h. Okay, so how is dv dt related to dh dt if r is constant? Now remember how I said that, like when you actually have the problem, we only can plug in what's constant. So now we're going to pretend it's constant instead of as a variable.
I don't have a good imagination.
Hey, if it makes it easier, make it a number.
Oh, okay.
Make it a number and just see what happens when you have that number. Like so for part A, it says if r is constant. Well, think about, here, if you're having trouble imagining r as a constant, look at pi. Pi is a constant, right? How do we treat pi?
As a constant.
As like just a coefficient, right?
Yeah.
It's just a coefficient. Does it disappear?
No.
No, does it just get multiplied to everything?
Yeah.
So think of pi r squared, that whole part is a coefficient.
So, oh.
Okay, so think of v equals, so pi r squared h. This whole thing is a constant, it's a coefficient. So really when I do the implicit differentiation, I'm just going to do the derivative of v and the derivative of h. And we leave pi r squared alone. Does that make more sense now? So if I do d dt of both sides,
Thank you. Thanks, Elise.
so we get dv dt equals pi r squared dh dt. Questions?
Does product rule not apply? Because.
Because it's just a coefficient.
Got it.
Okay? Treat this like any coefficient that you would encounter. It just gets multiplied to the derivative. And h, the derivative of h, is just dh dt. And then, okay, so now for b, you want to do the same thing, but now h is constant. So if it helps you, rearrange some things. Make it pi h times r squared. Right. Now, pi times h is going to be some coefficient. So what would be the derivative now?
Indeed.
So
dv
dv dt is going to be pi h times 2 pi, or sorry, times 2r
So just be.
dr dt.
So
That's a
2
T.
pi r h dr dt.
Yeah, dv dt is 2 pi r h dr dt. Okay with that one? All right, number 3. What if neither r nor h are constant? So, no constants for r and h. So now pi is the only constant. So I'm going to put pi with the r squared. It helps to, if you have a lot of stuff going on, just kind of break it up into two parts so you can do the product rule. So you have pi r squared is one part, and then h is the other.
Wouldn't it be easier to put h with the pi?
Sure, it makes absolutely no difference.
Okay.
But if you prefer that,
Then I don't know.
okay. So we're gonna do d dt of both sides. You really do get the same thing. I mean, it's not, whether you pair the pi with the r squared, I just kept it in that order just to make. So the left side dv dt. Okay, so we're gonna do the derivative of this. So, actually, let's leave pi r squared. Pi r squared times dh dt plus 2 pi r dr dt times h. And there's not really anything we can do with that. We could just move the h in front, so it's pi r squared dh dt. Usually with related rates, you put the related rate part after everything else. So I put 2 pi r h dr dt. We're just going over homework. Good?
Can you go back up to D for a second?
Sure. So this was just practicing doing the implicit differentiation part with d dt of both sides. I mean, really, we weren't solving for anything, we weren't substituting anything in. We were just practicing doing the implicit differentiation and treating one as a constant and the other as a constant. So notice we get different results depending on if one of them's a constant. That's why I said we don't usually plug in. We only plug in if we know it's a constant. Otherwise, we leave everything alone until the end. Are we okay with that?
So that was just a proof of concept.
Let me just put in a whole bunch of blank pages. Okay,
Excuse me, I read this one and I got it.
you got it.
Five, I think.
Number 5?
I think so.
Okay, so we can go through.
I think I got it.
You think you got it. Anybody else think they got? Let's see, 5. X, Y, Z are lengths of edges of a rectangular box. Okay, so S is equal to the square root of x squared plus y squared equals z squared. That's basically like the distance formula in three-dimensional space. Okay, the
Wait,
diagonal.
plus z squared, right? You said
Isn't
equals.
it?
Oh, I'm sorry, plus z squared.
Ends up being 1 over the square root of.
Yeah, so I'm going to rewrite this. So the 1/2 power, and we want to take d dt of both sides.
Yeah.
Okay, so we have ds dt equals, so the 1/2 goes in front. Everything on the inside stays the same. This is the chain rule.
Woo.
And then what goes on the outside? Negative 1/2 power. And then everything on the inside we have to do the derivative of with respect to t. So inside the parentheses we're going to get a what? 2x dx dt.
Plus
Same for all the others? Bless you. So 2y dy dt plus 2z dz dt. And that's basically it. Now, they moved everything, so they put this, since that has a negative exponent, we put that on the bottom. And then notice the 1/2 and all the 2's would cancel, right? If we were to distribute the 1/2 to each of those parts, so we get x dt plus y dy dt plus z dz dt. Is that what we got? Or if you are doing this for the first time, it makes sense?
Yeah.
Question mark? Okay. That's a lot to write, yes.
I have a question.
Yes.
Is there gonna be like another step that like we use this for, or is
Yes.
this just it?
The first few problems in this assignment are
Here we
just
go.
practicing doing the implicit differentiation.
Here we go.
Now, you could encounter a problem like this, maybe in a multiple choice question on the AP exam, where
That's
they
different.
just want you to find the related rates. But usually, after the first step, like, the thing about multiple choice type questions, you can look and see your answer sometimes without doing all the work for it. Like, you could see that the 1/2 and the 2's cancel, so you're not gonna have to write as much work when you actually do the multiple choice. Hopefully you'll be able to see some of them as you go through. Or you'll be able to like rule certain ones out. Like they'll do ones with the chain rule and they'll purposely have one where they forgot to do the chain rule, you know. It's like the obvious
The obvious
incorrect
one wants
answer.
to be careless.
Right, unless you're going through it too quickly. Okay. How about 7?
Yay.
Yay? Is that where we
And here we go.
Here we go.
Let's
Okay, so
start-
we actually have
let's
to
start
plug
the
in
heavy
here. Okay. So we have voltage, changing voltage. So we have an equation, right? V equals IR. Suppose that V is increasing at the rate of 1 volt per second. So when I read something like that,
dV
remember
dt is-
that's dV. Of course, V in this case is not volume, it's
Voltage.
voltage. So that's going to be 1 volt per second. Remember, the dt on the bottom means it's always a change with respect to time. Right? That's the whole purpose of this. Related rates have respect to time. And then what else do we know? We know that I is decreasing, so that's important, di dt. If it says it's decreasing, we know it's negative. So di dt is decreasing at the rate of 1/3 amp per second. And, okay, so for part A, we just want to find the value of dV dt. Does it say anything is constant?
No.
No. So
So
we're
we
not,
can't
we're not
use-
gonna assume anything's constant at this point, and we're not gonna plug any of our values in.
Even if it
Wait,
gave it to us.
even if they gave it to us. Well, we differentiate first, and then we look to see what we can plug in. So for part A, we're just gonna do d dt of both sides. What do we have to do on the right side? Do I have to do the product rule?
I guess so.
You guess so. Just because I
So,
said it?
Because they're not constants, that's when you.
Exactly. So they did not give us anything that was constant here.
And they'll tell us if something you want to
They
be
give us
constant.
anything constant? Let me double check. Okay.
The reason they give us numbers is because in A and B they ask for
Yeah, because it says what's the value of dV dt?
for C.
Well, let's see. So this is going to be I dr dt plus
R.
di dt r.
No, that's the answer for C. Why in the world wouldn't C?
Oh, okay. Hold on. Wait.
It's for A is 1.
Yeah, the answer.
Oh, yeah. For A, it's just. I'm sorry.
Yeah, that's why I was confused.
That was here.
They gave
This
it to
is
us.
A. Yeah, they gave it to us. That's, okay, they were just making sure that you could interpret
Read a
that.
problem.
Read the problem, which I did, and then didn't realize it when we were looking at A. So hold on. I'll erase this. And then for B, oh, so B is this. Okay, so A and B weren't solving for anything. It was just interpreting the information in the problem. So then for C, write the equation that relates dr dt. So on that, we already did.
That's what this is. So
And
I-
now,
Yeah.
So find the rate at which R is changing. So that's dr dt. When V equals 12 and I equals 2.
So those are the constants.
Yeah,
Just
so
plug them into part C. if
so
it is.
for part D, that's what we're finding. So
But
dV
we
dt.
plug D into
Yeah, so now we plug in everything that we know.
into C. Into the equation.
Yes, so 1 is equal to,
No, you don't.
2 dr
It
dt
changes that.
plus negative 1/3 times r, and r was, oh, they didn't give us r, but we can figure out what r is equal to.
Wait, so
What's wrong?
don't they give us different values in D? Yeah. And V is 12. They changed it, don't they?
And I used to, and
Right, but there's no place for us to plug in
Oh,
v.
okay.
So I'm gonna plug v and I in here to get r is 6, because that's what I have to use in my formula. Do you see here? We're plugging in dv dt was 1, I is 2,
Where? Oh,
di
it gives
dt
us
is,
I. Okay.
and r we had to plug in here to figure out. Got a lot of arrows going on. Hopefully they all make sense. Do they all
So
make
it only
sense?
gives I.
Kind of. Okay, so we're basically just figuring out what dr dt, and then I think the other part of the question was, is it positive, negative, or something about interpreting. Here we get what, negative 2, and then add 2.
3/2.
So we get 3/2 for dr dt. So dr dt is 3/2, and that's ohms per second. And it's increasing. Increasing. So if you get a positive value, it's increasing. If it's negative, it's decreasing. Hopefully that is straightforward enough.
Changing the messages in the rectangle.
All right, how are we doing? That was number 7.
9 is long.
9 is long.
9 is like, it's like the same thing. I just don't know why I got a weird answer
Okay.
for C.
So let's take a look. Number 9, we have a rectangle. And the length, so here's length, width. The length of a rectangle is decreasing. So dl dt is decreasing at negative, or we should say negative 2 centimeters per second would be the rate. While the width, so dw dt, is increasing, so that's a positive 2 centimeters per second. When L is 12 and W is 5, find the rates of change of the area for A, B, perimeter, length of diameter. Okay, we get the idea. Diagonal. Okay, so for each one we have a different formula. So let's look at the first one. What is the area formula?
Length times width.
Okay, so notice I'm not going to actually plug in any values yet, because remember, it's changing. Nothing's staying constant here. So length times width, do d dt of both sides. Well, this assignment, I know that many of these are long, but it was supposed to be a 2-day assignment anyway. We're just a couple days behind.
So we're still gonna do this. We're gonna review tomorrow and then test it. It's gonna be on.
Yeah, I think we'll be able to get through. Let's
the
see.
test would be Tuesday.
20 after 9. I'm hoping
Why
we'll
would
get
we-
through most
oh,
of
we
this
don't have
assignment.
possible- yeah, right.
And then I have a review worksheet. It's kind of like optional, but gives you a good idea of what types of questions you would be expecting on the test
From this
from this
section.
section.
These
And then I
sections.
have the practice test. I have everything today, so if you want to start it today, that's fine. But
Is the test long?
no, it's not. I mean, it's.
We have.
I'm
the-
actually not done with the test yet. So.
We also have the bonus period.
Yeah.
What day are we taking the test?
Next Tuesday.
Okay, so we're good with that? This product rule again with implicit differentiation. So what do I want to find? I want to find the rates of change of the area. Okay, so when L was 12, it said W was 5. So now I can plug in. So 12 dW dt was 2 plus 12 and
No.
negative 2
Five.
times 5. So dA dt is 14? And that's going to be what units?
Centimeters squared by second.
Okay, so far? Now, that was that was all part A, right?
Yeah.
So now for part B, we want to do the perimeter. What's perimeter formula? 2L, 2W, it doesn't matter the order. So when I do the derivative, this one's actually easier because you don't have to do the product rule or anything. Just, well, how do we treat the 2's? Those are just coefficients, so they just get multiplied to the derivative. So we have dp dt, so many d's and t, and then 2 dl dt, and 2 dw dt. So we have 2 times negative 2, and then 2 times positive 2. So what do we get? 0. And that's centimeters per second. Does that answer make sense?
Yeah.
Yeah, because if we're talking a linear measurement, so as the length is getting smaller, the width is getting bigger at the same rate. So, and notice we didn't even have to plug in L and W.
So
It's
zero
kind of
just
irrelevant.
indicates that it's the same rate.
Yeah, they're
as
basically
what it's reading.
they're canceling each other out. So as the length is getting smaller, the width is getting bigger at the same rate.
But if the length and width were changing at like
Different.
-2 and 3, there'd be an answer.
Yeah, so what do you think? If the length was -3 and the width was +2 in terms of how they're changing,
To change it 2
what do you think the perimeter's gonna
to
change?
-2 centimeters.
So it would be negative.
Yeah.
So it just depends
Yeah,
if they
yeah.
cancel each other out or not. Okay, C was the diagonal.
I don't know the
Okay, so let's go back here. We need to come up with an equation
Okay, no,
for
the
representing that.
diagonal. I mean, now I
L equals square root of L.
Let's just call this let's call this x.
X squared.
So L squared plus W squared equals x squared. We agree with that?
yeah.
So then if I'm solving for x, it would be the square root of L squared plus W squared. So I'm going to say x is the square root of L squared plus W squared. So x being the length of the diagonal. So if I do d dt of both sides, what do we end up with here? Just chain rule, right? Power chain rule. So the 1/2 goes in front. And then we have inside stays the same. Take away 1 from the exponent. And then we want to multiply by the derivative of the inside with respect to t. So that's going to be 2L dL dt.
DW.
So if it makes you feel any better,
Oh, yeah.
this is as far as we go with derivatives, I mean, in terms of like difficulty. So it doesn't get any more difficult with derivatives.
So we want to have.
This is like the last of the derivatives that we do, and then starting chapter 5, we start working backwards. So
What do you mean working
the
backwards?
anti-derivatives.
Oh.
I'm just saying that this, if you can do this, pat yourself on the back. You're doing a good job.
Because we
That
got the
this,
farthest
you
with
got the
easier
furthest
stuff.
that we got as far as we're going with
Which-
derivatives.
Which is the easier stuff out of the year or the harder stuff out of the year?
It's all the same. This is, students usually think when we get to what happens with related rates is we don't do so much of it second semester and then students forget how to do it. But if you get it really well now, hopefully when we do the AP review, or, I'll try to make sure that we do some practice problems in between, you're in good shape. Because there's always a lot of not a lot, but there's almost always 1 or 2 free response questions with related rates. So that's why we're doing a lot of the homework. I know it's repetitive, but I want you to get it. Okay, now what? Plug it all in?
It's the same as that other problem.
It's the same as that other problem?
Yeah.
Because the 2's, the 1/2 and the 2's all cancel. So we have L, dL, dt. If you want to plug it in now, that's fine. Oops. So W, dW dt, all over the square root of L squared plus W squared. So L was what, 12?
Yeah.
And negative 2 plus 5 and 2. 12 squared plus 5 squared. The answers are not on this page. Anybody have an answer for that?
13 over
Negative
12.
14.
I got 14,
Negative
13.
14 over 13.
Negative 14 over 13.
Negative.
And this is
Oh, yeah.
centimeters per second because it's just the diagonal. Okay. 11?
What, 9B.
Oh, I forgot. Oh, which of these quantities are decreasing and
Oh.
increasing? Okay, just go back and look.
Do we have to do it?
Just here. We'll just write it in. This one is increasing. How about B?
Neither.
Right? That's a neither. And decreasing? There you go. That's part D.
Yay.
Okay, 11. Inflating a balloon. So a spherical balloon is inflated with helium at the rate of 100. So that's a dV dt because it's 100 pi cubic feet per minute. How fast is the balloon's radius increasing at the instant when the radius is 5? And then for part B, how fast is the surface area increasing at that instant? Okay. Any ideas?
A volume of
What's the volume formula for a sphere?
4 pi r.
Okay, 4/3 pi r cubed. So I want to do dV dt of both sides. Now the nice thing with a sphere is that you only have one, basically, it's only dependent on the radius. Whereas when we had a cylinder, if we have a cone, or some other shape, a pyramid, you have a radius and you have the height. Okay, but we just have radius here. So we treat, so with 4/3 and pi are just all a coefficient. What do we get? dV dt is equal to,
4/3 pi.
how about 4 pi r squared dr dt?
Oh, right, 'cause they're 3 and 3.
Which is, if you, some of you may recognize, or may not, that 4 pi r squared is the surface area of a sphere.
Is that how they found it?
They do relate. It's just like when you take the area of a circle and you do the derivative, you get the circumference.
Now we plug in, we know what we know.
Now we plug in what we know.
Can we
Oh,
derive that?
what's that?
Can you derive that?
Yeah, you can. Oh, we don't. But I don't think I even have in any of my
Oh,
math
you like get
classes.
excited when you said that? Oh, I thought you lost.
Okay. So 100 pi.
And then you said we don't, you lost. That's how you lost.
Oh, and this is when the radius is 5, so.
Right.
So basically you get 100 pi on this side, 100 pi on this side, so dr dt is 1. And the units are foot per minute.
why isn't it? Oh, it's a radius.
It's a radius, so just linear measure. Okay. And for part B, how fast is the surface area increasing at that instant? Okay, so for part B, what is surface area?
4 pi r squared.
Okay, we just talked about that, 4 pi r squared. So let's do ds dt. So that's going to be, whoops, that's an 8. 8 pi r dr dt. If you do are you okay
Oh,
with
and then
that?
we
You ready?
plug in dr dt. We know
Ah,
what it is.
because we just figured out at that instant it's 1 foot per minute, so we can plug that in.
Be it.
So ds dt is 8 pi. What was the radius at that instant? It was 5. And then 1. So we get 40 pi. And it's going to be, right, square feet per minute.
I don't think
What's wrong?
oh, it's how
Air traffic control, yeah.
We're getting through
my
them.
dream job.
Let's see, we got to what, number 11
Different than flying.
of 1 through 25 odd?
But like, I'm gonna need it.
That was a long assignment I gave you.
I think you should just.
We done it.
We just got an email about the internet.
How do they expect us to get an email about the
Checking your
internet
emails
if we
in
don't
class.
have the internet?
Everybody has their phone, that's how.
It says we have to restart all of our computers. I'm not in the mood to do
My
that.
computer doesn't do that.
Yeah, no.
It
I
says
don't know.
just please restart your
Okay, yeah, the Surface Pro 3 is working fine.
Okay.
Jordan. Okay, let me do a little,
Can you skip to 19? 'Cause,
do you want me to skip to 19? You guys got 13 on your own? Oops.
Wait,
Whoa.
you can do that? That's how it shows up in the screen guys? You just snip it?
I just snip it.
That's insane. That's
What's,
like
it's a
Photoshop.
snippet tool.
That's just like Photoshop, but within like a snipper. Sneak, sneak.
The snippet tool, I don't know, don't you have something like that, similar? Like a clipping tool?
Concussion? He like hit his head.
I don't know, I don't feel like drawing it over again. Remember, my drawing skills are very limited, and
Yeah, you're like.
this is
So,
so much better than me trying to draw an airplane. Trust me.
I want to see your airplane.
No, you do
Look,
not.
this person
Okay,
drew a
stop
fire
stalling.
balloon
Okay.
just like yours.
Okay,
All
I'm
right.
on the book. I can't read the problem.
So, 13. An
Yeah,
airplane?
13.
We'll get there, we'll get there.
That's
I'm
true.
sorry. It is kind of true, isn't
You
it?
just snipped it. That's
All right, well,
It's not within the internet.
we'll see. Well, maybe you guys can do this one on your own. No? An airplane is flying at an altitude of 7 miles. So, 7 miles.
Is the height.
That is constant. So we actually have a constant here.
So H is 7.
So H is 7.
Or Y is
Or
7.
Y is 7, however you want to label it. When the plane is 10 miles from the antenna,
Then S.
so when S, they even say when S equals 10, the
Oh,
radar
S.
detects the distance S is changing at the rate, so dsdt, just going to write that in. So dsdt is 300 miles per hour. What is the speed of the airplane at that moment? So how are these three, well, we have 7, X, and S.
We could find X, but we
Okay,
don't.
how do they relate?
Don't we? We're looking for DXDT.
Okay, so we're looking for dxdt.
Equals S.
Okay, so we could use Pythagorean theorem. X squared plus 7 squared equals S squared. So we want to do
Do we
D.
know S squared?
Remember, the airplane
Yeah,
is
it's
moving this
moving.
way and
It's
this way. So
moving.
these two are changing. The only one that's staying constant is that the airplane is staying at 7 miles above ground. Like it's not, we're gonna assume that it's just, I mean, obviously there's gonna be
that
some
sounds-
fluctuation,
that
but,
sounds about right.
but for practical purposes, we're just gonna,
Oh.
the only thing we could plug in is the 7. So we get 2x dx dt. What happens when I do the derivative of 49?
0.
0. And then we get 2s ds dt.
There you go, Lindsay. That's good.
So the 2's cancel. It doesn't really matter. Right? I can cross out the 2. So x, it said when x was, what was the problem? It was when x is,
Nothing.
oh, it didn't give us that. It said s.
We had to solve S.
So when s equals 10, what would x be equal to?
Were we given the
Square root of?
Were we given DX? Oh wait, DXDT is what we're looking for.
Square root of
100 minus 49, so
no,
squared-
Not 149. Was.
Square root of
51.
51. We're good with our mental math. Okay, so now we can plug. So x is square root of 51 times dx dt, which is what we're trying to find,
Can you guys stop talking?
equals 10 Okay, so we want to plug in 300 then. So 3,000 divided by root 51 is what we have. And it comes out to be 420.08 miles per hour. Sounds about right.
When S is 10.
When S is 10. So when S is a different value, it's going to have a different, oh, oops.
Spelling words.
Yeah, that was Owen's spelling words.
Yeah, go Owen.
They're nice words. I know.
They weren't they?
Better than I do.
He's got some trouble with his writing.
That's okay.
Let's just say his writing does not take after his mom. It's okay. It's all good. What's that?
Whose organization skills?
Madeline's got the organization. Owen,
Her writing,
Okay,
her
the little
writing
boys
better.
aren't that like organized.
and definitely
What
not
are Owen's
organized.
names?
Oh,
So,
no.
like O.
Look,
Uh,
Meister.
Was Batman and
Oe?
Oh boy.
He doesn't have any nicknames
Okay.
really.
His initials are okay.
He's okay. Those
Does he have a middle name?
He does. It's P.
Oh, no, I like okay.
Okay, for number 15, how much did Lincoln pay to get their name book?
What?
The car company.
What car company?
Lincoln
Number 15.
Automotive.
I don't know.
You know, I really think they're catering to the wrong crowd.
Yeah.
Yeah, one high school AP.
Gonna be honest.
Calculus students want a Lincoln.
A Lincoln. I don't know.
I'm a senior, not a senior citizen.
Oh.
The navigator.
All right. Do you guys need?
Can we do 15?
Do you really want to do 15? The mechanics at Lincoln Automotive are reboring a 6-inch deep cylinder to fit a new piston.
Are we allowed to look up these formulas? I don't remember.
I know, yes, you can look them up. For purposes of this test, I do give you the formulas, but we review them when we do the AP, so hopefully by the time you're ready for the test, you know. They're not gonna, if they give you some kind of weird shape, they're gonna give you the formula, but they expect that you know cylinder, cone, and sphere, and
I don't know
prism.
any of those.
So we'll review those, that's what we'll review. What's that? It could be either. Okay, so you could put them into your calculator, but you could encounter it on a non-calculator section. All right, so here, so a cylinder. The machine that they are using increases the cylinder's radius 1,000 of an inch every 3 minutes. How rapidly is the cylinder volume increasing when the bore diameter is 3.8 inches?
Can we skip this one? Like knock it off the homework? I just.
It'll make Lincoln feel bad, and we can't do that. He's a good president.
Okay, so we wanted
I think all the other.
yeah, so let's see here. We want DVD. Well, let's write the cylinder formula is V equals pi r squared times h. Okay.
Okay, 1,000 with an inch every 3 minutes.
Every 3 minutes.
So does that mean we have to divide it by 3? to get
Right.
per
So the DRDT, they gave it to us as 0.001
minute? Per 3 minutes.
inch per 3 minutes. So we can figure out what would that be. I mean, it would basically just divide it, right, to get it per inch or per minute. Oh, and it said it was increasing or decreasing? Increasing. Okay. So how rapidly is the cylinder volume increasing when the diameter is 3.8 inches?
0.0003.
So here, okay, so it says it's reboring a 6-inch deep cylinder. So is that's going to be our height? I think that's constant, if I remember. I don't remember doing this one last year. Right, here's our radius. So they're taking it, and I'm guessing that they're taking it, it's 6 inches deep, but they want to increase the radius?
We're gonna bore from the.
Or they wanna bore it in the boom? That's right.
But they use the right diameter, not
We
radius.
need the radius, it's 1.92.
Yeah, so when R is equal to 1.95?
No, it's just 1.9.
1.9 inches. Yeah, but I think it's
Why is it 1.9?
because the diameter.
3.8.
It's 3.8.
Oh.
No.
Hold on. I want to write something down, Tom. Okay. Just want to make sure I was plugging everything in right. Okay, so, yeah, this is constant.
Maybe like show us an easier way to do this. Does it stay this hard?
What's that?
Does it stay this hard? It's like really easy.
So I'm actually going to I'm going to rewrite, well, since the height is 6, it's 6 pi r squared. So when I do the derivative of that, it's going to be 12 pi r dr dt. And then we can plug in. The radius is 1.9 and basically 0.001 over 3. And we get 0.02.
This would be a calculator
Four.
problem.
Yeah, this is definitely a calculator problem.
This is difficult.
Yeah. I think for this one, it was just understanding. I wanted to make sure that the h was constant. So they have the depth, but the radius is increasing. Okay.
They're mass producing cars, they should get a faster machine. Settings.
Yeah?
You wanna do a good job, Jordan, it's a luxury.
Yes, it's a luxury car. Okay,
Oh.
No, it's not. Those Ford SUVs are crap. Sorry.
This is a lean.
My mom got a lemon.
oh, okay.
Got a what?
A car that had nothing but problems.
Oh, you know what? Number 17.
Yeah.
17 is just like the one, it's very similar to the one in the notes. Do you need me to go through that one?
I guess not.
Do you want to try it on your own and then report back to me tomorrow?
Okay.
It's similar to the one in the notes because it's a conical tank. The difference is it's draining. So dV dt is going to be negative.
Yeah, do the whole thing.
Okay, so I'm just going to say see notes and then you let me know if you still have trouble with that one. So let's look at 19. 19, is that where we had trouble?
Yeah, just 19.
Finally. So I can skip right to C?
No.
You should do all of 19.
Here. Let me copy and paste my picture here. Yes.
Maybe on the thing that you're writing on, if you write for 17, then do it in 7.
Oh, they gave it in different units and expected you to change it.
Who did? 17? Which one?
Or we could just not do 17.
Oh, it's
Well, considering we're doing pretty much all the rest of the homework,
Well, we're not doing the even.
You wanna just give us some unit conversions, please?
Yeah, if you ever want good practice for the test, do the even
Wait,
ones.
what's the unit conversion? In where, 17?
17. So you want me to write down, oh, that's for part B. Yeah, just note change in units.
So you just divide the meters you get by.
Yeah, meters is, meters
Okay.
compared to centimeters. So centimeters, how many centimeters are in?
Time.
Okay, that's all.
A billion.
Yeah, that's-
Okay, here we go. Number 19. This is, I believe I have something similar to this on the test, so you might want to start it. So a 13-foot ladder, like here's our 13-foot ladder, is sliding, or sorry, it's leaning against a house, and the base starts to slide away. So you can see the arrows, the ladder is falling. And so as it goes out this way, the top of the ladder is falling down. Okay? By the time the base is 12 feet from the house, the base is moving. So we'll call that dxdt. Is that positive 5 feet per second or negative?
Moving pod. right.
It's going to the right, it's positive direction. And this is when x equals 12. Now, we do have something constant. That is the ladder. It's a 13-foot ladder, so that's not going to change. So we needed something relating x, y, and 13.
Why do you assume that the house is constructed so it can be good to the ground?
Really, don't go there. Just don't go there.
Jordan, you know what happens when you assume? Thing happens.
I have 43 physical, baby.
Wait, do you,
Yeah?
don't we have to find that y or no?
Yeah, we can find. So when x
I know
equals
what-
12, what's y equal?
5.
5.
You did DT.
I see that now.
Oh, we're getting the spirit of this case.
I know.
Oh,
I already got that school spirit down.
What is that?
that case.
Okay, so we plug everything in. The 2's are kind of irrelevant again. We agree? We could divide everything by 2. So if you want, you just cross them off to just make it a little easier. So x is, we said x was 12. dx dt, that's what, sorry, that's 5. That's what we were given. And then y is 5. dy dt. Now, just looking at the problem, is dy dt going to come out positive or negative? Negative. The ladder is falling down. The distance is getting smaller. And what do we get for dy dt?
You don't need to.
Oh, I think they probably, you know why? They wrote how fast. How fast is speed?
Oh,
So
speed is-
if you wrote negative 12 feet per second, the speed of that is still 12 feet per second, just the absolute value. So how fast is the top of the ladder sliding down? 12 feet per second. Now, for part B, at what rate is the area of the triangle formed by the ladder and the wall and the ground changing at that moment? So now, what would be a formula for the area? So this was part A.
Base times height of 2, right?
Okay, so 1/2 base times height. But the base and the height are
X and Y.
x and y. So dA dt is going to be 1/2 x dy dt plus 1/2 dy dt.
Where's the Y though?
Oh, you're right. Hold on, I mixed. Let me rewrite that.
Oh, 1/2 Y dx.
It's 1/2, here if I group these together, it's 1/2 x times dy dt plus 1/2 y dx dt. There we go. So 1/2 x is 12. dy dt came out to be negative 12. And then 1/2, and then 5, and then dx dt. Was that 5? Does that sound right? So dA dt comes out to be negative 119 over 2. I hope.
Or you just like, do that in your head?
Nope, I just looked in the book.
I was really bad.
I have the teacher's book
It
here.
is negative 119.
It doesn't have all the answers, so I kind of glance up, like most of the ones in the beginnings. Some of them were there, and some were on a different page. So I just put them in. But and then what was part C? So part C was the part that we had the question on. In the back?
Angle theta. Oh.
So at what rate is the angle theta? Here's theta. What is that? How is that changing? So I got to do this on another page. What relates theta? Sine, cosine, tangent. So we have to look at, so we want to know between the ladder and the ground. So we want, at what rate is the angle theta between the ladder and the ground changing at that moment? So tangent? No, you want to do, you want to do cosine?
Ground and
Yeah,
ladder.
round and hot.
Ground is X, ladder
don't have one
is
constant.
Okay. I'm not so sure. Hold on. That's what I'm thinking, tangent.
But it's
Be-
the ground and ladder. It says ground and ladder.
Well, honestly, but they're saying at that moment.
Yeah,
That's what I'm wondering. Well, that's what I'm thinking because we know x and y, and we know that we
Doesn't
solve
matter,
for the
you'll
rates.
get the same I feel like you'll get the same.
You
number.
think so? We should try it. You know so? Okay.
So which one's the easier derivative to do? We'll do that one.
So you think cosine? I don't know. I'm trying to remember this one and why. Let's see. Cosine of theta is going to be what?
X over
X over
13.
13. So if we do d dt of both sides, okay, so that's going to give us negative sine of theta, d theta, dt, and then it's going to give us 1/13 dx dt. Now theta, we need to be able to solve. So remember, it was a right triangle here. So this was 5, this was 12, this was 13. So could we figure out, well, actually we can just plug it in. What's sine of theta? It's opposite
5/13.
over hypotenuse. So it's negative 5 over 13 d theta dt equals 1/13, and dx dt was 5. Is that right? Okay. It did work out. Okay. So negative 1, and that's radians per second. So you're right, it should work out either way, because we have all the information and it's at that instant. So whether you use x, y, or the 13, so whether we use sine, cosine, or tangent, it should still work out the same way.
Use cosine. Like if you did tangent, then you could figure out these secant squared, and then you'd have to take
Then
the
you have
Tangent,
inverse.
oh, we have to use the 13.
You'd use the inverse of secant and then calculate it, and it'd be harder.
It would be way harder.
Well, because it's easy to mess up.
But no, you don't have to plug anything in though, because you know the opposite and adjacent sides.
Fine, we got the answer.
It should work in regardless of which one we use.
Yeah, it'll work. It's just one.
Yeah, one might be harder than the other.
Alright, next question.
How far did this go? Up to 25? And then
Figure out the rate at which we're doing a problem.
I really assigned a lot. I don't remember assigning this much last year.
You did just one to see the answer. Okay, we'll do it. 34 looks interesting, but I'll think about that.
It looks interesting.
Well, I just like the title of the talk.
Oh, I can't copy this picture very nicely.
Why not?
Hold on.
Walkers.
The words are.
Oh, that's you.
I'll just,
Yeah.
because that will bother me, I'm just gonna clip the whole problem. There we go.
Why? Why do you do this?
I can't do this one.
You know, why aren't you putting it well?
Because
What's
I
wrong?
don't have a digital copy of the book and it's kinda hard to clip from a physical book.
I just cut it out.
It is with that attitude.
You could take a picture of yours.
You could take a picture.
It's a waste of
Okay.
time.
So a dinghy is pulled toward a dock by a rope from about through a ring on the dock 6 feet above the bow, as shown in the figure.
Yeah.
The rope is hauled in at the rate of 2 feet per second.
That's the.
You do a shoot on it.
What's that?
What do you wanna call it? I wanna call it X.
Oh, you want to call this? Which one you want to? You want this one to be X and this one to be Y?
We already have.
We have it at 6 feet. You're right.
This case if I'm all out of can.
We need this is.
What? I'm all out of can.
What do you want to call that? Z, do we need Z? I don't like using Y because then Y always to me represents a vertical distance. So it's fine. If you technically it doesn't matter what letter you choose. Okay, how fast is the boat approaching the dock when 10 feet of rope are out?
Z is 10.
So when Z is 10, we want to know dx dt. That sound about right? No. Let's see. At what rate is the angle theta changing at that moment? Okay, so that's kind of a different question
So
relating
we
to
know
theta.
y equals 6.
So we know y equals 6.
Z is 10.
The Z, we know the rope is hauled in, so dz dt is positive or negative 2 feet per second.
Negative.
Because it's pulled in. So we want to find for part A dx dt when z equals 10. Right? And if z equals 10 and this is constant at 6, so then that would make x equal 8. So when z equals 10, x equals 8. So we're going to relate the 3 for part A with x squared plus 6 squared equals z squared, and then do the derivative. Can I skip some steps or not? Yeah. No skipping steps? Because it'll be the 2x dx dt plus 0 equals 2z dt. And then the 2's will cancel? No, you still want me to write it? Because I was just going to write dx dt equals z dz dt. It is. It's a long one. So we're going to plug in 8. dx dt is what we're solving for. Equals 10 times negative 2. So negative 20 over 8. Again, it asks for how fast. So it does come out to negative 5/2 feet per second. But when it says how fast, it's 2 feet per second. And then for part B, at what rate is the angle changing at that moment? So we want to figure out d theta dt. How would we relate that? You want to do cosine again?
Sure. Why?
Tangent?
Because then you have squared. You have to deal with
don't think it make,
Well, we know Z.
do,
Z's 10. Oh, is Z's 10?
it's at that moment, so yeah, we can plug in those.
Plug them in automatically?
Well, it's the same moment. It's that same moment.
Yeah, but for going forward, we didn't know.
Okay.
Yeah, if it's the same moment, you know.
You wanna
nothing
use
changed.
it doesn't matter, guys, we could do
Stop
tangent.
debating and start writing.
Tangent theta, let's just do tangent theta, let's just try tangent, you guys don't. So x over 6,
I think we did.
We did X over 13.
so secant squared of theta, d theta dt,
No, but then we did negative sign. We did 5.
equals 1/6 dx dt. Now, secant, what is, if you look back at the picture, secant is going to be hypotenuse over adjacent, right? So,
It's like use the things
It's
that
not
we
what I
know.
was saying.
We do that in the other one.
the hypotenuse over the adjacent side would be what? Plug that in. Square it. We can plug in dx dt. No? Are we having, I think SOHCAHTOA. I know, it's too much. You guys getting tired now?
Yes, we
Wait,
took a break.
secant is
Let's finish up this one and then,
hypotenuse over adjacent. But
so what do we have?
10 over 6.
So 10 over 6 and then we square that?
Which is 136. No, wrong. Yes, right. No, I don't know.
So if I do secant,
What are you concepts for?
it's 10 over 6, so 5 over 3 squared, so 25 over 9? Yeah, just, okay.
'Cause that's
d
10,
theta
6,
dt.
20.
I simplified. And what's dx dt? Negative, what's wrong? Yeah. Didn't we just find out dx dt was
Yeah.
negative 5 halves?
Yeah.
So solve for d theta dt. Something doesn't look right there. Wait, where am I looking?
25 over 9.
Hypotenuse over the adjacent side to theta would be 10 over 6. 10 over 6 reduces to 5 over 3. Square the 5 over 3. We get 25 over 9.
Isn't it 1 over that?
I got the hand.
Well, I just went right ahead and did secant. Okay, when I have the triangle, it's easier for me to just look at hypotenuse over the adjacent. But if you want to do adjacent over hypotenuse and then take the reciprocal, it's all the same. I'm hoping that,
I got the hand.
I'm hoping I did everything correctly.
You did.
And we get negative 3 over 20
Yeah, I did.
radians per second. Okay, I think we're